This is section 2, algebraic approach to limits, example 2. So in this problem, we're dealing with piecewise functions. Piecewise functions are basically everything we were looking at in the graphical approach to limits, right? So where they'd come together at a point or maybe not come together, and there'd be like a jump discontinuity somewhere, which we'll talk about next time. And those are piecewise functions looking at the graph. If we don't get a graph, if we just get an equation, the thing we really need to focus on most of the time ends up being where it switches from one equation to another based on the domain that's given. Now, before we do anything, we need to read the problem. Okay, the best way to get a problem wrong is to not read the problem, and we'd like to get problems right if possible. So, if you look at part A, it says find the limit as x approaches 2, if it exists. All right, well, if you look at the piecewise function, the domain is split where x is 2. So it doesn't matter which ones are equal to. All that matters is that the top one, the 3x plus 1, is to the left of 2, and the 2x times x minus 1 is to the right of 2. So we're going to plug it into both sides, because remember, a limit only exists if the left-hand limit is equal to the right-hand limit, and we're going to use that nice notation. So first, let's find the left-hand limit. So we're going to find the limit as x approaches 2 from the left. Don't forget that exponent. It's the left-hand limit. And to do that, we're going to use the top equation. So we get 3 times 2 plus 1. And again, all we're doing is plugging it in for x. And we get 7. All right, we're going to do the same thing for the right-hand limit, only this time we're going to use the bottom equation. So we're going to have 2 times 2 times 2 minus 1. Well, 2 times 2 is 4. 2 minus 1 is 1, so 4 times 1 is just 4. So if you notice, the left-hand limit and the right-hand limit are not the same. So the limit as x approaches 2 of f of x does not exist. You might feel like writing the limit as x approaches 2 every single time is excessive, but it's not. It is absolutely required. Do not forget to write it down every time. It is very, very, very important. On the AP test, in the free response portion, they will take off points if you don't have that notation now. So keep that in mind. If you look at part B, now we're dealing with the limit as x approaches 0. And for this piecewise function, 0 is where it switches from one equation to the other. So we plug it into the left, plug it into the right, and see what we get. Again, just like on part A, the top equation ends up being to the left and the bottom is to the right because less than is left. Left, less than, right? Remember? So the limit as x approaches 0 from the left of g of x involves plugging 0 into this equation, and 0 plus 1 is just 1. The limit as x approaches 0 from the right, that's g of x, not f of x. If I plug in 0 to 2x squared, I just get 2. So once again, the limit as x approaches 0 of our function does not exist.